10th CBSE Chemistry, Chapter Carbon and its Compounds. In this video, you're going to learn about the chemical properties of carbon and its compounds, particularly the combustion reaction and oxidation reaction. Carbon undergoes a number of chemical reactions. In the 10th CBSE lesson, that is the carbon and its compounds, you're going to study the 4 important chemical properties or the chemical reactions of carbon and the compounds. The first is the combustion reaction, then it's the oxidation reaction, substitution reactions, and addition reactions. So these are the 4 major chemical reactions of carbon you're going to study in this particular lesson. But in this video, we are going to concentrate on the combustion reactions, the type of combustion reactions, and the oxidation reactions which carbon and its compounds undergo. So let's begin with the combustion reactions. Recall the winter night when you burned the firewood. How did you feel? You felt so good because of the warmth given out by the firewood. Now, burning of the firewood did give heat which warmed you up. But was the heat only thing which came out of the burning firewood? No. It also gave out the light. So heat and light are the important things which you noticed as you burned a firewood. Now, when you burn anything, any fuel, you would see these 2 things immediately. So what are the other things which you observe when you burn a fuel? You also observe the smoke and you also see the residue of ashes after the burning is complete. So whenever you burn a fuel, these are the things you observe. This process in which a fuel is burnt in the presence of air is given a name as combustion. Let's define the combustion now. Combustion. It's a chemical process in which a compound or a fuel is oxidized, producing heat, light, and new products like water, carbon dioxide, and ash. So as you can see, the definition tells that it is a chemical process in which a fuel is oxidized. Yes, combustion is indeed an oxidation process because it takes place only in the presence of oxygen. Oxygen is the oxidizing agent here which oxidizes the fuel to its respective oxide, that is the carbon dioxide and water. Recall the first video of the lesson in which you understood that most of the materials, the daily used materials and the matter around contains carbon in it. Carbon and its compounds readily undergo combustion reactions, producing heat, light, and new substances. When we consider the combustion of carbon, there are 2 types: complete combustion and incomplete combustion. So let's begin with the complete combustion. Now, this is a common sight in the kitchen. You observe the blue flames on the burner. The LPG gas burns with the blue flame and without soot. LPG, the liquid petroleum gas, is nothing but mixture of saturated hydrocarbon gases such as butane and propane. Not only the saturated hydrocarbon gases, but most of the saturated compounds undergo complete combustion. Now, let's understand what happens during the complete combustion. Taking combustion of methane as an example. So, methane is chemically CH4 and it undergoes oxidation reaction, which is nothing but the combustion reaction to produce carbon dioxide, water, heat, and light. As you can see, combustion reaction is also an oxidation reaction because oxygen acts as an oxidizer wherein it oxidizes the fuel to its respective oxide. The respective oxides are formed. So the saturated hydrocarbons generally burn in air, producing a large amount of heat. When you observe the flame during the combustion of a saturated hydrocarbon, it is non-sooty blue flame. This is mainly because the percentage of carbon in the saturated hydrocarbons is comparatively low and because of this it gets completely oxidized in the presence of air. Large amount of heat is produced which results in the high temperature, and this high temperature is responsible for the blue flame. So in case of saturated hydrocarbons, the percentage of carbon is less, and because of this it undergoes complete combustion. It undergoes a complete combustion in presence of sufficient amount of air. So air in the sense here we are talking about oxygen. Observe here. So here is the first image which you saw with the blue flame, blue non-sooty flame, and next to it only you can observe the yellow flame, right? Yes. You might have observed this while cooking. So something gets clogged in the gas burner and you immediately see a bright yellow flame. Now why does that happen? This happens because the holes in the gas burner gets blocked by the particles, which results in the insufficient oxygen supply to the fuel, and the incomplete combustion leads to the sooty yellow flame as you can see from the image. Now let's see the incomplete combustion of methane. So the molecular formula of methane being CH4 plus O2, that gives CO plus H2O. So let's balance the equation. 2, 3, so 2 here and 4 here. So now the equation is completely balanced. So when there is an insufficient supply of air, which in turn means the oxygen, the carbon compounds burn producing carbon monoxide. Let's take one more example. C3H8, which is propane, burns in insufficient oxygen supply, giving rise to carbon, carbon monoxide, carbon dioxide and water. See the product list now. So let's balance it. So it's 2 carbon monoxide, 2 carbon dioxide, and altogether 8 water molecules. So you can see here there are 1, 2, 3, 4 products formed when a propane undergoes incomplete combustion. So let's list the products of incomplete combustion. It's carbon monoxide, carbon, carbon dioxide and water. See, carbon, which is nothing but a solid, carbon dioxide, which is a gas again, carbon dioxide is a gas, and water molecule, which is again a vapor. An incomplete combustion always leads to more pollution. The unsaturated hydrocarbons usually undergo incomplete combustion. This is because the percentage of carbon in them is comparatively higher, whereas the oxygen supply will be limited. And this may not be sufficient for the amount of carbon which is present in the unsaturated carbon compound, which is usually high. So because of this, whenever an unsaturated hydrocarbon is burnt, it burns with a yellow sooty flame, producing a black smoke. But if an unsaturated hydrocarbon is burned in sufficient oxygen supply, then they too will burn completely, producing a non-sooty blue flame. And this is same for saturated hydrocarbons. When you are burning a saturated hydrocarbon in insufficient supply of oxygen, they too burn with a sooty yellow flame. So the major factor here is the supply of oxygen, and hence it is always advised to burn the fuel with a sufficient oxygen supply so as to ensure an high efficiency of fuels. But one thing you have to notice in all this is that the fuel is getting oxidized, and hence the combustion reaction can also be called as an oxidation reaction. Observe this oxidation reaction in which an alcohol is oxidized to form its respective acid, that is the carboxylic acid. Here we see that the alkaline potassium permanganate or acidified potassium dichromate can oxidize the alcohols to acids, that is adding an oxygen to the starting material, giving rise to the carboxylic acid as the end product. So let's do a quick recap of all that we have learned in this video. Carbon and its compounds can undergo four main types of chemical reactions. In this video, we mainly focused on combustion reaction. There are two types of combustion, complete and incomplete combustion. So we saw that combustion can also be called as an oxidation reaction. There is one more method in which the carbon compounds get oxidized. Like for example, the alcohols get oxidized in the presence of alkaline potassium permanganate or potassium dichromate solution to form the carboxylic acid. So in this video, you learned the combustion reaction and oxidation reaction in particular.